Hello guys, we are going to discuss one of the multitasking questions of Kaplan kit, and the question is related to Care Company. Care Company needs to replace a major piece of office equipment that is in constant use and for which there is expected to continue to be used for the foreseeable future. Two types of machines are available with different capital costs, useful lives, scrap values, and annual running costs. Machine 1 will have initial cost of 480,000, however a life of 4 years, scrap value of 60,000 and annual running cost of $72,000. Machine 2 will initially cost 540,000, have a life of 3 years, scrap value of 120,000 and annual running cost of $47,000. Care Company's cost of capital is 10%, assuming all cash flows except the initial capital cost occur at the end of the relevant year, and assume that taxation and inflation can be ignored. What is the equivalent annual cost of machine 2 to the nearest $1,000? Now firstly, let's write the formula of equivalent annual cost. The equivalent annual cost formula is the total NPV divided by the annuity factor. So firstly we need to find out the total net present value of the machine, and then we have to divide it by the annuity factor. So let's first calculate NPV. So machine 1, so we are supposed to calculate the equivalent annual cost of machine 2, so we'll just be discussing machine 2. Machine 2 will initially cost 540,000, so that's our initial cost, which is $540,000, and $540,000. Then we have scrap value at the end of, obviously at the end of the life of the machine, which is 3 years. So scrap value, and it is 120,000. And since initial cost is a cash outflow, so we should be writing it as a negative figure. And what we have annual running cost of $47,000 running costs, and these will be spent every year, $47,000. So what we need to do is we need to find out their present values. These are our cash flows. So we need discount factors and annuity factors to find out present values. Initial cost is spent at 0.0, so the discount factor for this cash flow will be 1, as these are the cash flows for year 0, 540,000. Scrap value is going to be received after the end of 3 years, so we need to have a 3 years discount factor, and the formula is 1 plus the discount rate, which is 10% in this case, 10% raised to the power minus 3, as life of the asset is 3 years. So here we go, we've got the discount factor, and we just need to multiply to find out the present value. So the present value of the scrap value is 90158. Then we have 47,000 annual running costs, and these will be spent every year constantly. So we can't use discount factor because discount factor only represents a single year. These cash flows will be spent every year for 3 years. So there are 3 cash flows, and we have to find out the present value of these cash flows using annuity factor. So the formula for annuity factor is 1 minus 1 plus rate, 10%, raised to the power minus 3, and then whole divided by the rate, 10%. So that's the complete formula. Make sure that while using Excel spreadsheet, you use brackets wisely and you don't make mistakes while using the brackets. So let's just multiply. That's the present value of the running costs, and let us now add all these 3 to find the net present value. So here we go, we have got net present value of the asset over 3 years of life. So we are done with the first step. We have calculated net present value, and now we have to find out equivalent annual cost. For equivalent annual cost, what we need to do is we need to pick up this NPV and divide it by the annuity factor equal to the number of years, 3 years, right? In this case it's 3 years. So we have already calculated annuity factor for 3 years, so we'll just simply use this one. So I'll just divide NPV by this annuity factor, and here we go. We've got the equivalent annual cost. But if you just look at this requirement exactly, to the nearest $1,000, so we have to round it off to nearest $1,000. We have a formula in Excel to round it off to nearest $1,000, and but we can always do it manually as well. It's 227,888. So if you can just look at it, this figure is either equal close to 27,000, or it is close to 28,000, right? So just think for a while and just tell me, this figure is more close to 27,000 or 28,000? Yeah, it's more close to 28,000. So the answer that you need to insert here will be 228,000, right? So they've already used these zeros here, right? So you just need to place 228. So let's round it off using the formula of Excel, round, R-O-U-N-D, round, and it asks for number of digits. So we are rounding it off to 3 zeros, right? We are going to round it off to nearest 1,000. So for that we need to place a minus sign, and since we need 3 zeros at the end of the figure, so I'll just insert 3 here. So it's 228,000. So the equivalent annual cost of this machine is 228,000. So we're done with the part A. Now let's go to the part B. Part B. What does it say? It says drag and drop the relevant statement to indicate whether they are true or false. We just need to mention whether these statements are true or false. The equivalent annual cost calculation assumes the same type of machine is going to be used into foreseeable future. Obviously that's is one of the assumptions when we are using equivalent annual cost. So we'll be using the same machine. Say for example, if we are using machine 2, which is going to be replaced, which has a life of 3 years, so it means that after 3 years we are again going to buy machine type 2 after 3 years, and then we'll continue on replacing the same type of machine after every 3 years, in case we have decided that we are going to have machine 2. So that's the assumption. So machine statement 1 is true. The equivalent annual cost calculation assumes the capabilities of machine 1 and machine 2 are identical. Yes, that's the second assumption. The reason is we have to choose between the two machines, right? Machine 1 and machine 2. So if they are not identical, it means their purpose will not be the same. And if their purposes are not the same, how are we going to choose between the two? Obviously you will never be choosing between a car or a cupboard, right? Because they have two different purposes. So whenever you have to choose between two options, the two options should be fulfilling your same purpose. So you might be comparing one car with the other car, because you might be willing to buy a car to travel, to use it for travel purpose. So like with like will always be compared. So second option is also true. So both the statements are true. So then we have got the C. Okay, it is now felt that the final scrap value of the machines depends on two factors: whether or not a new supplier enters the market, which would reduce the likely scrap value. So if the new supplier enters the market, your scrap value will be reduced, because there will be someone else also providing the same type of machine. So obviously when you get a competition, the prices go down. And the strength of the dollar against other currencies, since the sales of used machine will be made abroad and invoiced in the foreign currency. So if your local currency strengthens, it becomes more expensive against the foreign currency. So the exporters will always lose when the local currency strengthens, because you will have less number of local currency units against the foreign currency. So if you are an exporter and your currency appreciates in value, it means that by selling your machine in the foreign currency, you will receive foreign currency, but when you convert the foreign currency into your local currency, you will get less number of local currency units as your currency is expensive. So here what it says, if the dollar increases in strength, the scrap value will be reduced. So how much? The adverse effects of will each reduce the scrap value by 10%. So if the new supplier enters the market, whatever your existing scrap value is, it will be reduced by 10%. But if the dollar also appreciates in the value, you will lose a further 10% value from of your scrap value. So there will be 10% reduction because of new supplier entering the market, and if your local currency, that is dollar, strengthens, you will lose a further 10% as well. But these two things are not certain. A new supplier might enter or might not enter the market. The dollar might strengthen or might not strengthen against the foreign currency. So what it says, what's the probability of a new supplier entering the market? It's 40%. So there's 60% chance that the new supplier may not enter. On the other hand, if the probability of your currency getting strengthened is 30%, and it will stay the same, the probability will be 70%. So there will be 70% probability that it will stay the same. What is now the expected value of the scrap proceed from machine 2? Now it's talking about machine 2, and as we just discussed, that the current scrap value without these uncertain events, it is expected to be 120,000. So first of all, let's find out the possible outcomes. Now, supplier entering the market, dollar strengthens, right? So one of the situations might be that the supplier enters the market, yes, and the dollar also strengthens. So your existing scrap value is 120,000, right? The existing scrap value is 120,000. So if the supplier enters the market, it will be reduced by 10%. So if it is reduced by 10%, it will be reduced to 90%, right? So let us assume that we are dealing with only one uncertain situation, and that is supplier entering the market. So if this is the only case, then the scrap value will be reduced by 10% and it will be 108,000. But since we are assuming that the dollar will also strengthen, so a further 10% decrease will be there in the scrap value. So we'll multiply it with another 90%. So this 90% is because of this condition getting true, and this 90% is because of this condition becoming true. So we'll multiply it by 90% twice. So the expected scrap value in this particular situation will be 97,200. So one of the possible outcomes, possible scrap values, will be 97,200, right? So the other chance will be that supplier enters the market but dollar does not strengthen, right? So the current one is 120,000. So in this case, just think for a while what we are supposed to be doing. Are we going to multiply it by 90% twice? No, we are not going to multiply it by 90% twice, as only one condition is becoming true. So we'll just multiply it by 90% once. So one of the possible scrap values will be 108,000. Then we might assume that there is no new supplier is entering the market, no, but the dollar is getting strengthened. So again, we have 120,000 scrap value, and again only one condition is becoming true, so we'll just multiply it by 90% once. This is another possible scrap value that we may be getting. And then we may have a situation where neither the new supplier is entering into the market, nor the the dollar is strengthening against the local foreign currency. So 120,000. So in that case, there will be no change to your scrap value. So your scrap value will be expected as 120,000 if this happens. So there are four possible scrap values that we may have, but none of these have 100% chance of occurrence. So we'll be using joint probabilities, because each of these depends on these two uncertain events. So we'll be using joint probability. So let's just use the short form JP, joint probability. Don't use this short form in your exams, because obviously you may confuse the examiner. So joint probability will be, we just need to multiply the probabilities of these two events. Yes, and the yes has a probability of the new supplier, yes, and the probability will be 0.4, so 0.4 into again yes, and it has a probability of 0.3, so 0.4 into 0.3. So if by multiplying these two probabilities together, we will get a joint probability which will tell us the chances of getting this and this scrap value. So there is 12% chance that we might get this scrap value, because this scrap value will be received when these two conditions are true. So 12%. Similarly, we'll be doing this for the rest of the situations as well. So again, we have the yes situation, which has a probability of 0.4, 0.4, but now it has a combination with the no one, which is 0.7, so multiplied by 0.7. So there's 28% chance that we might be getting this scrap value. And then we have no yes, no, this is 0.6, and we have yes, yes of dollar, yes 0.3, 18% chance. Then we have both no's together, 0.6 and 0.7, 0.6 into 0.7, that's 42%. So if you just add all these possible probabilities, the answer will be 1, as you know that the sum of probabilities will always be equal to 1. So now we need to find out expected value. For that, we need to multiply the possible outcome with its probability. So there is 12% chance that we might be having a scrap value of 97,200. So multiply. Then we need to multiply these two, and then we have to do the same for the rest of the values. And then we have to add these values together. And this is going to be our expected scrap value. That's our expected scrap value. This is what the answer is. Triple 1,744. So let's see what exactly here we go. Which answer? 111,744. So the closest answer should be picked. 111,744. So I guess this is the most closest answer, right? 111,600. That's the closest answer. And maybe they haven't used a spreadsheet to calculate their answer. That's why there is some difference in our answer, and that might be because of rounding off. So 111,744. That's the answer. I hope it's clear. Now let's move towards the next one. To overcome the difficulties of incorporating probabilities into investment appraisal calculations, Care Company could perform simulation exercise to help reach a decision. Drag and drop to indicate whether the following statements relating to simulation are true or false. It eliminates the effect of risk associated with various estimates. Now, simulation model does not eliminate any effect of risk. It does not reduce your risk. It does not eliminate any chance of loss, right? By using simulation, you cannot stop loss from being incorrect. So the loss outcome will still be possible. All it can do is it can help you project or predict the possible outcome and help you take a decision. Say for example, as you know that we were just expecting that the scrap value may fall, and the scrap value may reduce. So by using simulation model, we cannot stop the scrap value by getting reduced. All we can do is we can stop ourselves from buying machine 2. That's it. So maybe we avoid buying the machine 2, but we cannot um, stop anyone from entering the market by simply using the simulation model. So simulation model cannot stop any possible outcome from its occurrence, but it will help us take a decision by projecting the possible outcome. So it's a false one. It requires probabilities of estimates subject to risk to be known. Yes, a simulation model does use probabilities. It does use probabilities. So second option is true. Second statement is true. Which of the following statements about care company's replacement decision are true? The decision between machine 1 and machine 2 could be found by calculating total NPV of each machine over 12-year period. So one of the machines uh, had a useful life of 4 years, the other had a useful life of 3 years. So if we take LCM of the two figures 4 and 3, it will be 12. So one of the ways through which we can decide which machine the company should be buying is to calculate NPVs all over the same time span, that is 12 years for both, because 12 years is a figure that will be exactly divided by 3 and 4. So you can exactly divide this figure by 3 and 4, and this is called LCM method. So we have equivalent annual cost method where we calculate average cost per year, and we have LCM method where we take a common time span for both the options, but that time span or the figure of that time span should be exactly divisible by the two options that you have. So that's true. The replacement analysis model assumes that care company replaces like with like each time it needs to replace an existing asset, and that's what we've discussed in a while ago, that when we are using equivalent annual cost method and where we have to decide the replacement cycle of a machine, we assume that same type of machine will be replaced every year. So both the statements are true. So which option? Yeah, it's option B. So I hope you have got this